Here are the things you need to be able to do. Describe the transformation, identify asymptote, domain, or range, and graph using the asymptote and 3 points. Let's start with exponential functions. If you have a parent function, we can transform the parent function by having a horizontal shift, right, left and right, or a vertical shift up and down. This a value, if the a value is negative, then we have a reflection over the x-axis. Okay, this is also a vertical stretch or shrink factor. Let's take a look at this example here. Notice that my parent function is y equals 2 to the x. So because the base is 2, if we're multiplying by 2, my numbers are getting bigger. Therefore, I know it's an exponential growth function. It's going to look something like this with an asymptote at y equals 0. But because I have that minus 3 inside and the plus 1 outside, I know I'm going right 3 and up 1. So I can think of it as going right 3. Remember, I'm creating my new x-y axis and up 1. And I'm just going to shift that graph from there. So I know that my new asymptote right here, okay, my new asymptote is going to be at y equals 1. My domain is all real numbers, as all the x values can be used. Range is y is greater than 1 because all of my points lie above that asymptote. So now let's do the part where you actually have to sketch the graph using the asymptote and 3 points. So I know my asymptote is at y equals 1. So y equals 1, I've drawn my asymptote. Remember, I know that my basic sketch is going to look something like this. I just need 3 specific points now. So one way to do this is to use the parent function and make a little table. I need 3 points. I'm just going to plug in 3 points that I feel are easy to use. So plug in 0, I get 1. Plug in 1, 2 to the 1 is 2. Plug in 2, 2 squared is 4. So I'm going to plot these 3 points from my shifted xy coordinate plane. Remember, I went right 3, up 1. So if I go right 3, up 1, I'm going to use this area right here as my new xy coordinate plane to just plot my parent function. So I can go ahead and plot 0, 1. So 0, 1 will be right here because, again, I'm taking care of the right 3, up 1 by just shifting the entire xy coordinate plane. So 0, 1, 1, 2, 2, 1, 2, 3, 4. And I know that the basic shape is an exponential growth function. So that is my final graph. All right, here's another example. Notice that my base is 1/3. So my parent function, right, is going to be 1/3 to the x. So when I multiply numbers by 1/3, my values are getting smaller. So I know this is going to be an exponential decay type of a graph. But there's some other stuff going on. So this negative out here makes it a vertical reflection or a reflection over the x-axis. And this 2 right here, it's a vertical stretch by 2. So all the y values are going to be multiplied by 2, vertical stretch by 2. And then this plus 4 out here, you're shifting the entire thing up 4. So let's see what the basic sketch would look like with the transformations. I know I'm going up 4, so this is going to be, and it's not going anywhere left or right, so this is like my new xy axis. So my graph, 1/3 of the x will look like this, but because I have that -2 on the outside, I know it's a reflection, and it's going to be a vertical stretch. So it's going to look something like this guy right here for my final graph. So using that to help me, I know my asymptote is at y equals 4. Domain is all real numbers, all the x values are used. Range is y is less than 4 because all of my points lie below my asymptote. So if you have that reflection over the x-axis, you're going to have a range that is y is less than the value of your asymptote. Now let's go ahead and actually sketch this graph using 3 points. So I am going to take care of the h, k, right? H, k, there is no h, right? So h, k, by making my new xy coordinate plane. So this is like my new xy coordinate plane. But I know that y equals 4 is my asymptote, so I'm just going to make that dotted line there. And because I took care of the x, h comma k, I can just use whatever I have left over. So it's really the parent function with a reflection and any vertical stretch or shrink factor. So you're really just going to be ending up with this guy here. Okay, you're going to make a table using that. So I have y equals -2 times 1/3 to the x. Let's go to make a table. Find 3 easy points to plug in. So one easy point would be 0, right? If I plug in 0 right here, 1/3 to the 0 is 1. 1 times -2 is -2. Okay, so now let's think about what easy values might be to plug in here, right? And I know I'm going to eventually multiply by -2. So I can go ahead and plug in 1. If I plug in 1 for x, I get 1/3 times -2, which gives me -2/3. And I could go ahead and plug in 2 if I wanted to, but I would get like -2/9. So instead of plugging that in, I'm going to go ahead and plug in -1. Do you see why -1 might be a nice number to plug in? So let me go ahead and show you. If I have that, remember that negative exponent? Here, what does a negative exponent do? It flips the inside, right? It flips the base. Right? So that's going to give me -2 times 3, which is -6. So if you have a fraction as your base, you may want to try negative numbers for your input so that you can get nicer numbers out. Let's go ahead and plot these points. We're plotting 0, -2, 1, -2/3, -1, -6 on my shifted xy coordinate plane. Remember, I took care of the h comma k by just shifting the entire xy axis. So here's 0, 0. I'm plotting 0, -2. And I'm plotting 1, -2/3, and -1, comma -6. So here's -1, comma -6. 1, 2, 3, 4, 5, 6. Okay, so I have a point here, here, and here. So you really do need to know what the basic sketch is going to look like if you want to have success graphing this, because if you have these 3 points here, you know, that could be anything, right? But we know that this is a reflection of an exponential decay. So, you know, getting closer and closer to the asymptote there, and it's coming down. So there is my final graph. Let me go ahead and guide you through this U-try problem. What would the transformation for this function be? So you should have a vertical shrink by 1/2, left 1, down 3. Okay, go ahead and find the asymptote. All right, the asymptote is y equals -3. Now go ahead and find the domain and range for this function. Okay, domain is all real numbers, range is y is greater than -3. So remember, if you have a base 4, you have an exponential growth function, so it looks something like that, right? You're going left 1, down 3, so if I go left 1, down 3, and I just shift the entire thing, right, you're going to have a sketch that looks like that. Right? There's no reflection, so your range or domain is not going to be affected by that a value. So again, my domain is all real numbers, range is y values existing above the asymptote y equals -3. Okay, go ahead and pause the video and sketch using 3 points. So I took care of the h comma k, the left 1, down 3, by shifting the entire coordinate plane. So I went left 1, down 3. So then I'm just left with this portion right here, right? So I made a table of values, getting 0, 1/2, 1, 2, 2, 8. So let me go ahead and plot these points from my shifted xy coordinate plane. So 0, 1/2, 1, 2. 2, so that's 0, 1, 2, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, again, I know this is what my sketch looks like, so I can follow that. It's an exponential growth function that's been shifted. There's my final answer.